Let's start பண்ணிக்கலாம். Very good afternoon to everyone.
Okay, sir.
So today's session, I welcome everyone for this third day of session 2 faculty development program. So today's session will be handled by Mr. Ram Kumar on centroids and center of gravity topic. So I welcome you for this presentation, and you can share your screen and you can start your session, sir. Thank you.
Thank you, sir. So first of all, I thank the principal sir, vice principal sir, head of the department, and the FDP coordinator for giving me this opportunity to present a topic on centroids and center of gravities. So as we know that this topic, center and center of gravity, is covered in unit number 3, which is the properties of solids and surfaces. So here I have given the topic as centroids and center of gravity, because in the provided 1 hour span, I'll be able to cover the topics on centroids and center of gravities. So if time permits, then we will go to the moment of inertia and the other topics. So first of all, before going to this particular centroids and center of gravities, we need to know why or what is the main purpose for us to know this topic. Because in engineering mechanics, in unit 1 and unit number 2, first of all, in unit 1, we have covered how the forces are acting and about the system of various forces and their effects, sorry, not effects, and we'll be finding the way to find the resultant, also various names. There are a variety of system of forces which are there, like linear, concurrent, non-concurrent, non-concurrent. This we have a different set of forces. So we various methods by which we are able to find. சொல்லுங்க சார்.
சார் கொஞ்சம் ஆமாங்க
வாய்ஸ் இன்க்ரீஸ் பண்ணுங்க. ஓகே சார்.
இல்ல வாய்ஸ் ஓகே, ஏதோ டிஸ்டர்பன்ஸ் வர மாதிரி இருக்கு.
அது நெட்வொர்க் இஷ்யூ சார்.
இருங்க சார், நான் பார்க்குறேன்.
ராம்குமார் சார், விண்டோ கிட்ட போய் உட்காருங்க. விண்டோ அந்த அலுமினியம் பீடிங் ஏதாவது இருந்தால் அங்கே உட்காந்து கரெக்டாக.
ஓகே சார். இங்கே கால் அதான் சார். ஓகே சார். சார் இப்போ ஓகே சார், பிரதீப் சார்.
இப்போ ஓகேங்க சார். ஓகே
சரிங்க சார். உங்க மைக்கை மியூட் பண்ணிருங்க சார்.
பண்ணிடுறேன்.
ஓகே சார். ஓகே சார். So in unit 1, we are discovering the topics, or we are investigating about the topics by which we are finding the value of resultant. So depending on the system of forces. Then in unit number 2, we are seeing about the effect of the forces on a rigid body. And before going to that, we'll be seeing what is a rigid body and what is a particle, and then what are all the broad classifications of engineering mechanics. And these are all things we have been studying in unit number 1 and unit number 2. So the main purpose of us to study this unit number 3 is that we are going to discover what are all the properties that are acting on a solid and a surface, and then to find the location where these points are getting concentrated. So in the diagram itself, you can see that there are certain simple examples of center of gravity, as well as we have a centroid. Okay, so now we can go into this topic. So first of all, the center of gravity of a body is nothing but a point where the entire weight of the object is getting acted, or the entire weight is getting concentrated. So the term CG, that is center of gravity, is usually given for the 3-dimensional objects or the solid objects. So for the solid objects, we'll be using the topic, or we'll be giving the name as center of gravity. And then the term centroid is usually deployed for the 2-dimensional surface or the 2D objects, that is a plane surface or a lamina. So for lamina, we'll be using the term centroids. So CG is for a 3-dimensional object, and then centroid is for a 2D surface or a lamina. So where the entire area, is getting concentrated. So for this, we'll be using the term centroid. Okay. So next, we are going to see the methods by which we can find this center of gravity and centroid. So generally, for finding the center of gravity and centroids, so we have certain methods. That is, by using the method of integration, we can find the value, and then by deploying the method of moments. So by that also we can find the centroids. So before going to that, we must know what is nothing but a centroidal axis, and then what is a reference axis. That is, let us assume this as an axis. So here we have the origin O, and here we have the x-axis, and then the vertical y-axis. So let us assume that we have an irregular object like this. So this is an
Kumar sir.
yes sir.
உங்களுக்கு இன்னும் அந்த ஃபர்ஸ்ட் ஸ்லைடு மட்டும் தான் காமிக்குது உங்களுக்கு.
சார் அடுத்த ஸ்லைடு மூவ் இல்லையா சார்?
இல்லை உங்களோட அந்த ஃபர்ஸ்ட் உங்களோட நேம் இருக்கிற ஸ்லைடு தான் இன்னும் விசிபிளா இருக்கு.
இப்போ சார் சென்ட்ரல் பிளேன் தெரியுதா சார்?
இல்லைங்களே.
சரி சார், நான் ஒரு திரும்ப ரீஷேர் பண்றேன் சார்.
ஓகே நோ ப்ராப்ளம். பொறுமையாக அவசரம்லாம் பண்ணுங்க. இப்போ ஓகே சார்.
இப்போ ஓகே சார். இப்போ வருது. சென்ட்ராய்டல் பிளேன் ஃபிகர் பை இன்டகிரேஷன்
அதுக்கு வருது.
ஓகே சார்.
ஓகே சார், கண்டிப்பா.
இந்த வெதர் கொஞ்சம் இதா இருக்கனால
நோ ப்ராப்ளம்.
ஓகே சார்.
ஓகே.
So here this axis OX axis and OY axis, so they are called the reference axis because they are having a contact at the lowermost part of the object as well as in the left hand extremity of the object. Okay, so this is nothing but our reference axis, and then we have studied about an axis called the local axis. So again same, this is X origin O and then Y axis, and here we have an object. So let us say it is a rectangular object. So this particular rectangular object is at a distance of x1 from the OY axis, and it is at a distance of OX. So it is at a distance of y1 from the OX axis. So this axis is called as the local axis, but just by using certain local coordinates we are determining that. And next one we have the natural coordinate systems, NCS. So NCS, in NCS we will be taking the axis which is passing anywhere inside the object, not center but anywhere inside the object. So the axis has to pass anywhere inside the object, so then it can be called as a natural coordinate system. But here we are going to see a term called the centroidal axis. So this centroidal axis is nothing but an axis which is passing through the centroid of the given object. For instance, let us take this as a rectangle, and for this rectangle we have the centermost point O. So here the axis is not at the center, so for approximately we are telling that let this O be the center of this particular lamina. So here you can see that the axis OX axis and the OY axis, so they are passing through the center point or the centroidal point of this particular axis. So then they are called as the centroidal axis. So generally they are denoted by x bar and y bar, or sometimes as x bar axis and y bar axis. Okay, so this is a simple terminology on the different type of coordinates. So now let us see how we are able to find the centroid and center of gravity of a given object. So in order to find that, we have two methods. So one is by the methods of integration, and the other one which is coupled with the method by which we are using the moments into picture. So first of all, consider this as an object. So let this be an object. So it is having certain thickness T. Okay, so let this be the x-axis of the object, and let this be the y-axis, and we have the thickness axis Z. So let us assume that this object is having certain area A, and let us assume that since this particular object is attracted by the force of gravity, and we all know that all the gravitational force will be acting or will be concentrated towards the entire center of the earth. But for practical reasons, we'll be denoting that all the forces which are acting on it are parallel to one another. That is, to talk in a simple context, here I am discretizing that object into a variety of smaller elements. So let this be a point 1, and it is at a distance of x1 and y1 from the x and y axis, and let this be a point 2, and this particular point 2 is at a distance of x2 and y2 from the OY and OX axis, and then I have a point 3. So this particular point is at a distance of x3 from OY axis and y3 from OX axis. Okay, so let W be the entire force, that is the gravitational force which is acting on this. So since I am discretizing this into some three different points, let me take the values as del W1 and del W2 and then del W3. That is the a portion of the weight force which is acting in this particular points 1, 2 and 3 respectively. So if I want to find the resultant of this entire force, what I can do, I can just add all those values. That is, I can say that this W is equal to del W1 plus del W2 plus del W3. So this entire thing will give me the value of the force W, that is the total weight force, that is W. Then my major point is to find the point where this entire forces are getting concentrated. So that is my objective, or that is my motto. Okay, so for that what we are doing is we are taking the method of moments. So we are taking the moments, that is, we know that the moment is nothing but the force into the perpendicular distance. So wait a minute, so let me close the door. Sorry sir, sorry for the interruption. So here, so if you want to find the moment about of the weight to W along the y-axis, if you want to find along y-axis, I am using the term x bar into this W, so which is equal to the moments of all individual weights, that is del W1 into x1 plus del W2 into x2 plus del W3 into x3, because this is our OY axis and here we have our OX axis, and this is the point number 1. Okay, and here we have the perpendicular distance x1. So we told that the force is getting concentrated at point 1 with the intensity del W1. So here you can see that. So this is del W1, and then at 2, at point 2 we have del W2. So this is for del W2, and then here it is for del W3. So put this force into this perpendicular distance for y-axis, and the same del W2 force into this perpendicular distance. So by the way, we are writing that as the moments about the y-axis is equal to the total weight W into x bar plus the sum of moments of individual weights. So similarly, if you want to find the moment about the x-axis, so now we are going to use the perpendicular distance, that is y. So for OX axis, y1 is going to be the perpendicular distance. So thus we have, so y bar into W is equal to del W1 into y1 plus del W2 into y2 plus etc. up to del Wn and yn, sorry, xn. So then our main objective is to find the value for x bar and y bar. So what we will be doing, we will be taking this x bar is equal to the product of this del W1, x1, etc. up to this del Wn, xn divided by W. And similarly for finding y bar, we will be using del W1 y1 plus etc. up to del Wn yn divided by W. So this is for a case of a 3D object. So if you want to find the same thing for a case of a centroid, that is broadly speaking, the term center of gravity should be used for 3D objects or the solid objects. The term centroid must be used for 2D objects or lamina. So now we are going to replace this, the value W, del W, as the weight density into the small area into its thickness, that is the thickness of the lamina. So here you can see that weight density is having a unit of Newton per meter cube, and then for area, that is del A, represents the small area. So for that we have the value as meter square, and for thickness we have meter. We can see that dimensionally they are same. So next, for replacing W, so when we replace W with the same weight density into the area of the entire object into the thickness. So now here also you can see that the weight density is in Newton per meter cube into meter square into meter. So again we get Newton on the both sides, and we can say that it is dimensionally homogeneous, or dimensionally it is right. Okay, so for finding the centroid, so we have to use the same formula. So we have to replace this del W with the given relation, and then W should be replaced with this W into A into T. So here you can see that all the terms, that is the term weight density and the thickness, so they are in common. So finally we get the term as y bar is equal to integral of x dA, so divided by the area, and then for y bar we get integral of y into dA divided by the area A. So similarly for this weights also we get the terms as x bar is equal to integral of x into dw, or the del w divided by w. So by the way, this is a standard template for finding any unknown object or some objects. So if at all, if you want to find the centroid or center of gravity for a square or for cube, so we have to use the same thing. So for that we know its area and we know the parameters which are involved in that. So by using that and by applying the limits appropriately, we'll be able to get the values. So now let me show the standard results which we have obtained for the objects like square, rectangle and other things. So for square we have, for mentioning or for determining a square or for representing a square, we can use only one side. So that is enough, because in a square all the sides are equal. So we'll be using a by 2 for x bar and y bar. So the distance between the centroid and the OY axis, so that is the x bar, and similarly the distance between the centroid and OX axis, so that is y bar. So here you can see that this distance is going to be a by 2, and for y bar also it is going to be a by 2. So therefore we will be using a by 2 and a by 2 for x bar and y bar. And similarly for rectangles, so for rectangle also we can see that the centroid will be at the joining points of the two diagonals. So for finding any centroid, so now let me come to the bottom line. So for finding the centroid, we have two different techniques. So one technique is by using the geometrical constraints, or by using the geometrical considerations. So these all objects, they are all having or following certain geometrical considerations or constraints. That is, if we connect the diagonals, we'll be able to get a midpoint, and that midpoint is going to be the centroid in a case of a square and for a rectangle also. For triangles, we'll be connecting the medians, and then for triangle also, for them we'll be connecting the medians, and they will be finding the point where they're getting intersected as the centroids. But for irregular objects, we'll be using the integration methods, and we'll be finding that. And the second method is the method of moments. And the third one is the method of integration. Okay, so these are also 10 standard results. So now let's move on to the centroid of a composite plane figure. So let us see for the centroid of a composite plane figure. So assume a case where we are having the object like this, that is here we have the OX axis, OY axis. We are having a rectangle, a semicircle, and then a triangle. So this is a case where we are having a combination of various shapes. So for this, in order to find the centroid, so we'll be using the formula, that is, we'll be taking the algebraic sum of moments of all individual areas about the reference point should be equal to the moment of the whole area about the same reference axis which you are going to take. That is the same thing which we dealt in the previous section. So there we used the term W into certain X bar is equal to del W1 plus del W2 etc. up to del Wn divided by W1, W2 etc. up to del Wn. So the same thing we are here, we are replacing the term W with area A. So therefore we get the term as the X bar is equal to A1 X1 plus A2 X2 plus etc. up to an xn. So the entire thing divided by a1 plus a2 plus etc. up to an. And similarly for finding the y bar, so for y bar we'll be using a1 y1 plus a2 y2 plus etc. up to an yn. So divided by a1 plus a2 plus a3 etc. up to an. So now imagine a case where we are having certain cutout part, that is some cavity. So let us assume that in this particular object we have number 1 as the rectangle, and number 2 as the semicircle, and number 3 as the triangle. So assume the case that we are having a cavity like this. So this is a cavity, it is represented by the number 4, and this is a circle. So in that case, what you have to do is we have to remove that cavity portion. We will not be adding the materials, we are subtracting the materials. So the same subtraction signature must be included in the formula also. So for this we have X bar is equal to A1 X1 plus A2 X2 plus A3 X3, so minus A4 X4 divided by A1 plus A2 plus A3 minus A4. So here you can see that we are removing that area because there we have a cavity. So this is the thing we have to be very careful, because we have to tell the students that so this is only a general syntax. So this general syntax works only when we have material that are present in that particular given figure. So if we have this like that, we have to use the appropriate minor signature or corresponding shape for denoting each shape will be so appropriate number for that section alone. So let us see some basic problems and then we will go to the center of gravities. So next one is the most important thing, which is the axis of symmetry. So the main thing, that is if you want to find the centroid of a regular objects which are symmetrical to any one axis, that is sometimes some object will be symmetrical to both the x and y axis. So for that case we can directly use the geometrical constraint and find the values. For instance, assume an object like this. So here we have a circle. So as far as the circle is concerned, we can divide that into two different halves like this. So here you can see that it is symmetrical to both the axes. So for that particular point, we can say this center point is going to be the centroidal thing. And next, symmetrical about x-axis. So first of all, symmetry is nothing but a thing that when you are bisecting an object, or when you are bisecting a lamina or a simple figure, if you are able to get two equal halves, so with respect to that particular axis, so then you can call that to be a symmetrical object. So in our +2 biology or things we might have studied a bisection of a frog or a bisection of certain things. So when you're using the term bisection, so when you're dividing that, we are able to get two equal halves. So if you want to split an apple, the structure of the apple is like this. cut that along the y-axis, so we can get denote cutting this on the y-axis. So I'm able to it will be like that because we can see that the center later like that, but in real case apple will not be only about x. You can say that it is symmetric. The same thing. So when we cut something, we must be able to get two equal halves, right? Next, symmetrical about y-axis. That is, along the y-axis, it has to be symmetric. D section or triangle are coming into this category. And last one is non-symmetric objects. So non-symmetric objects, it will not be symmetric for either x or y. So it will be unsymmetric for the both the cases. So this symmetrical things will help us easily find the value of the x bar and y bar. Next, let us see a simple problem. So here we can see that there are two rectangles. So rectangle 1, which is on the x side, which is extended along the horizontal one, and we have another rectangle which is stretched along the y-axis. So we have the dimension as 6 centimeter and then 2 centimeters. So similarly here we have it as 2 centimeters, and along the y direction we have it as the 8 centimeters. Sir, somebody is unmuted, sir. Do you want to say anything?
இல்லை சார், ஒரு டைம் ரீஷேர் பண்ணுங்க, அது ஸ்லைடு மூவ் ஆகல தான்.
சாரி சார்,
இப்போ ஜஸ்ட் ஃப்ராக்ஷன் ஆஃப் செகண்டில் மாறிச்சு.
இப்போ தெரியுதா சார்?
ஓகே சார், ஓகே, இப்போ ஓகே
சார். இந்த கிளைமேட்னால கொஞ்சம் நெட்டும் ஸ்லோவாக இருக்கு. ஏன்னா மற்ற நாள் இந்த மாதிரி பிரச்சனை வந்தது இல்லை.
ஓகே ஓகே ஓகேங்க சார், இப்போ ஓகே, இப்போ ஓகே, இப்போ நல்லா இருக்கு.
தேங்க்யூ சார். Okay, so for this, the general syntax we are using is x bar is equal to a1 x1 plus a2 x2 divided by the sum of the areas a1 and a2. And similarly for y bar, we are using a1 plus a2 y2 divided by a1 plus a2. One. So length into breadth, we get 12 centimeters. Sorry, it is in centimeters. And for A2, we get the value as 16 centimeters square. And then the next thing is we need to find the value of x1 and then x2 and then y1 and y2. So the first important thing is that we have to first sketch the reference axis. So this is my y axis, and here I have the x axis, and this is my origin O, where the x and y axis are intersecting. Okay, so first, as far as the element or the rectangle, we know centroid points, that is the point where the diagonals are getting coincided. So here we can say that it is going to be 6 by 2. So we get 3 centimeters. And then for y, so for y we have the point over here, which is the breadth divided by 2. So we get 2 by 2. The value is 1 centimeters. And now we are going to consider the second rectangle, which is of the edges 2 cross 8. So here we are considering this x bar value, that is the x2 value for the corresponding triangle 2. So this is the center point. So here you are going to get the value as x2, and then here it is going to be y2. So for x2, we are going to use 2 divided by 2 because that's nothing but the L by 2 value. So L by 2, we get 1 centimeter and y2. So while finding y2, actually this y2 is nothing but it is not like the centroid of a given image. It is nothing but the distance between the centroidal point. So this is the centroidal point of this particular rectangle. So the distance between the centroidal point and the reference axis. So here the reference axis is nothing but OX axis. So we have to take into consideration this 2 centimeters. So now I will write 2 centimeter and I have found the length to be 8. So I will just write 8 divided by 2. So I get 2 plus 4, that is nothing but 6 centimeters. So now when I apply this in the above formula, I get x bar is equal to the area at 12 multiplied by x1. So plus area 16 into x2, which is 1. So everything a1 plus a2. So 12 plus 16. So this will yield a value which will be in centimeters. And then similarly for y bar. So for y bar we'll be using a1 y1. So a1 is 12 into y1, which is 1 centimeter, plus a2 16 into y2 6 centimeter divided by a1 plus a2. So we get 12 plus 16. So thus we get some value of y bar in centimeters. So as far as mechanics is concerned, or any paper in mechanical engineering, the units plays a vital role. So without unit, we will not be able to tell whether it is in centimeter or meter or horses or buffalo or whatever it is. So unit is a very, very essential one. So and then finally we need to plot the centroidal axis. So let me go to the next slide. So this is the here we have the given image. So this is going to be the OX axis and then OY axis. Now the central points. So we have found the central points. Let us say for I think if we solve this, we will be able to get the value. So then we have to plot the points. So for roughly, I'm plotting that the central points are certain distance like this. So by finding the value of x bar and y bar, we need to plot the central points. There is a central axis. So here it is going to be the point of x bar comma y bar, and this x axis is going to be my central axis, and this y axis is going to be my central axis along y direction. So x dash and y dash. Right. So this is the final thing by which you are plotting the centroidal points. So we'll see another sum and then we'll go to CG. So in the next image, let us assume that we are having a cutout portion at the center. So let this be section 4. So for the same problem, so first we have to identify what are all the elements or what are all the figures we have in this composite plane figure. So composite is nothing but the combination of different figures as far as this plane figure is concerned. So first we have the rectangle. So this rectangle is having a dimension of 15 centimeter cross 10 centimeter. And number 2, we have a semicircle. So it is having a radius of 3 centimeters and its orientation is along the y axis. And then we have the third one, which is a quadrant. So this quadrant is having a a radius of 2 centimeters, and finally we have a cutout part, so which is a circle. So the circle has to be removed. So for this, the formula will be like x bar is equal to a1 x1 plus a2 x2 plus a3 x3 minus a4 x4 divided by a1 plus a2 plus a3 minus a4. So similarly, for finding y bar, we will be using a1 y1 plus a2 y2 plus a3 y3 minus a4 y4. So everything divided by a1 plus a2 plus a3 minus a4. The main thing we have to know that if you are having any cavity in our given composite plane figure, so we have to subtract that while finding the x bar and y bar values. Next, let us go to the center of gravity. So as far as CG is concerned, it is only for the three-dimensional objects. That is the point where the entire weight is getting concentrated. So we have certain x bar and y bar value for the CG, that is for finding the point G along the x and y axis. We have d by 2 and d by 2 and h by 2 for the case of a cylinder, and for a case of a cone we have a d by 2 and h by 4. And then for spheres we'll be using a d by 2 d by 2, and then for a hemisphere, if it is a ox oriented hemisphere, we'll be using d by 2, and for y axis we'll be using 3r by 8. Okay, so similarly, if we have a case like a composite lamina, assume that we have a case where we need to find the center of gravity of an object which is having more than one shape. That is let us say it is a composite solid. So for that, for finding the x bar, we have the definite formula, that is w1 x1 plus w2 x2 etc. up to wn xn divided by w. So but in the problem, the value of w will not be given, that is the weights will not be given. So if you want to find the weight, we can use the weight density into volume. So for a given object like this, the volume will be mentioned, the values of specific weight or the weight densities will not be given. So in that case, we have to consider all these things into a volume one. So we know that the weight W, so the weight is equal to weight density into volume, and we also know that weight density is equal to rho into G into volume. So now let us replace all these W1 values into rho G V terms and W as rho Vg term. So you can see that here are the W values, and that is the W1 W2 values are in the numerator, the value of W is in the denominator. So when we are using that, the value of rho and value of G will get cancelled. That is, if you are using, that is if the composite solids are made up of same material. So if they are made up of same material, then the value of rho will be same. So let's not bother about G, because G will get cancelled automatically. So we get x bar is equal to V1 x1 plus V2 x2 etc. up to Vn xn. So everything divided by V1 plus V2 etc. up to Vn. So now assume a case when the composite solids, so let us say there are three different shapes in a solid, and these three different shapes are made up of different materials. So one is made up of iron, one is made up of copper, and another one is made up of bronze. So in this case, you can see that the weight densities are varying because they are made up of different materials. So different materials exhibit different weight densities. So in that case, the formula will also get changed. So it will be changed as rho 1 V1 x1 plus rho 2 V2 x2 etc. up to rho n Vn xn. So everything divided by rho 1 v1 plus rho 2 v2 etc. up to rho n vn. And similarly for y bar, so for y bar we have rho 1 v1 y1 etc. up to rho n vn yn, everything divided by rho 1 v1 etc. up to rho n vn. So similarly for the case of same materials, we have y bar value as the value as v, the product of v1 y1 plus v2 y2 etc. up to vn yn, everything divided by the sum of all the volumes. So this is the case for the composite solids, that is if they are having a same material or if they are made up of different materials. So here you can see that the value of rho is same, and similarly assume a case when the value of rho is different. So for that we will be using the formula which is given in the bottom one. Okay, so now let us solve a simple problem in this, and then we'll go on to the moment of inertia concepts. So in this image we have a cylinder of certain height and it is having certain radius. It is placed under a sphere. So that sphere is having certain radius, and the point is that we need to locate the value of Cg, the point where the intermediate is getting concentrated. So first we have to indicate the elements. So first we have number 1 as a cylinder, and number 2 is our sphere. Right. So here we can see that when we divide this object into two equal halves, that is when we are cutting this or when we are bisecting this along the y-axis, we'll be able to get two equal halves, that is one half with this hemisphere and then a half of the cylinder. So we'll be able to get two equal halves like this. But in the case when we are dividing along the x-axis, we'll not be able to get a symmetric one. So here we are concluding that the object is symmetric about the x-axis. So when symmetric about the y-axis. So if an object is symmetrical about y-axis, we can easily find the value of the x bar. So this x bar is nothing but the major diameter or the major length. So here we can see that the major length is 8 centimeter by 2. So we get the value of x bar as 4 centimeters. Then our part is getting reduced, that is the complexity of the problem is getting reduced. We need to find only the value of y bar. So for finding y bar, let us deploy the formula y bar equals to v1 y1 plus v2 y2. So in this case we can see that a sphere is placed above a cylinder, that is both of them are solid objects, we don't have any cavity, so we need not bother about subtracting the terms. So we can directly add it, the product of volume and y1 plus v2 y2 divided by v1 plus v2. So first we need to find for cylinder. So for cylinder we can directly use h by 2 for the case of y bar. So you can see that the value of h is so that is for y1 the value is 5 centimeters, and so for volume we know the term pi r square into h. So by this we can get the volume in centimeter cube, and then we have a sphere. So for a sphere we need to find the value of y2, so which is going to be d by 2. But the thing is that we need to find the value only from the respective axis. So here we can see the different axes are passing on the bottom of this object, that is here it is O x-axis and O y axis along the vertical side. So this is for OY axis. So this point Y is somewhere over here at the radius R d by 2 comma d by 2. So now we need to find this radius R plus the value of 10. So that is the value of y2 from the x axis. So we have to add plus 10 to it, and the radius is mentioned as 4 centimeters. So therefore the diameter d and simply R plus 10. So 4 plus 10 we get the value as 14 centimeters. Next we need to find the volume. So for volume, you know the simple formula 4 by 3 pi r cube. So using this we can get the volume. And finally, when we deploy all these things in the relation, we get x bar is equal to y bar equal to v1 y1 plus v2 y2 divided by v1 plus v2. And similarly, yeah, for x bar we already found. So for this y bar, we get some value as 8.13 centimeters. So finally, we'll be plotting the respective values, and we'll be mentioning the CG axis. So this is for when we are two different materials, when they make a combined unit. So next, let's see a problem where gravity or the volume is going to get. Okay, so in this problem, we can see that we are having three different structures. So one is here we have a cone, and then here we have a cylinder, and then at the bottom we have a hemisphere. So this hemispherical thing is like a dent or a cavity. So we have to subtract this term. And moreover, it is given that all the materials are considered to be a homogeneous one made up of the same material. So therefore, our formula get shortened as V1 x1 plus V2 x2 minus V3 x3, because we are subtracting the hemisphere term from it, plus V1 plus V2 minus V3. And similarly for the case of y bar, we have V1 plus y1 plus v2 plus y2 minus v3 y3 divided by v1 plus v2 minus v3. And the other thing is that here the object is also symmetrical about the y-axis. So along the y plane, if we cut this object, we'll be able to get two equal halves. So then we can say that it is symmetrical about the y-axis. So since it is symmetrical about the y-axis, we can easily get the value of x bar. So this is going to be the major length divided by 2. So we get 1 by 2, the value was 0.5 centimeters. So now our problems get reduced to find only for the value of y bar. So for the y bar, we have to again find the y1, y2, y3 values, and then v1, v2, v3 values. And then when we substitute in this formula, we will be able to get the value of y bar. Case of in this CG. So initially, the first object is in which one object was stacked on the other. So there we were adding the material, so we will be using the addition symbol throughout. And in the second case, we saw there was a cavity, so we just separated the cavity. So here it is a case where we are first of all making a bore, and then we are adding a material to it. So here you can see that there is a which are one beneath the other. So first they have a cylinder like this, and then they have created a hole.
Ramkumar sir,
So they
can
have
reshare
created a hole. Okay, sir.
Okay.
Tirumari share pandra sir. Sir, is it visible, sir?
இல்லை சார் இன்னும் வரல. இப்போ ஓகே.
Okay, sir.
ஓகே.
So here we have a concentric hole diameter 100 mm. So it is the depth of 150 mm. So in a perspex cylinder of diameter 200 mm and 400 mm long, then the hole is completely filled with the lead. So using lead, we are going to complete the hole once again. So now we are going to get the center of mass
கொஞ்சம் நெட்வொர்க் இஷ்யூ ஆகுது.
கொஞ்சம்
வாய்ஸ் கிளியர் இல்ல ராம்.
ஆமாம், வாய்ஸ் கொஞ்சம் இதாகுது. நெட்வொர்க் கொஞ்சம் ப்ராப்ளமாக இருக்கிற மாதிரி.
அப்படிங்க சார். இது ஏர்டெல் ஃபோன் சார். ஆனால் கிளைமேட் ரொம்ப இருக்கு சார். அதான் ஓகே சார், நான் பார்க்குறேன் சார். ஒரு நிமிஷம் சார்.
சரி, ஓகே ஓகே.
சார் இப்போ கேக்குதா சார்? இப்போ ப்ராப்பரா ரீச் ஆகுதா?
இப்போ ஓகே தான் சார்.
ஓகே.
First of all,
ராம்குமார் சார் அப்படியே தான் சார் இருக்கு. அப்படியே தான் இருக்கு அந்த வாய்ஸ்.
அப்படியே தான் இருக்கு.
ஆமா, அப்படியே தான் இருக்கு சார். விண்டோ பக்கத்துல போயிட்டு ஃபோன்ல கனெக்ட் பண்ணீங்கன்னு வச்சுக்கோங்களேன். விண்டோ பக்கத்துல வச்சீங்கன்னா அந்த அலுமினியம் பீடிங் அந்த மாதிரி இருந்தால் கொஞ்சம் நெட்வொர்க் ஃபுல்லாக கவர் பண்ணும்.
ஆல்ரெடி அப்படிதான் வச்சாருன்னு நினைக்கிறேன் சார். மேபி அங்கே ஒரு மழை அதிகம்.
திரும்ப கனெக்ட் பண்ணி பார்க்குறேன் சார்.
ஓகேங்க சார்.
சார் இப்போ கரெக்டா பேச ரீச் ஆகுதா சார்?
இப்போ கிளியரா இருக்கு ராம்குமார்.
Okay sir, thank you sir. So here we are having a perpex cylinder, that is, it is a transparent one. Assume a thing, we have a plastic bottle. So if we pour some orange juice or some other thing, we are able to see the thing which is present inside. That is something like very transparent one. So the same thing here, we have a perpex cylinder which is made up of a resin oriented plastic thing like that. So there they have made a drill and then they are removing the part and then we are filling it with using a leaded one. So generally what students think is that they will see that there is an object like this. So what they will do, they will consider this perpex cylinder as the number 1 and this filled leaded part as number 2. Most students used to commit problems like this, but here the operation is like that. First we have a solid cylinder. So initially we have a solid cylinder and then we have made a drill or we have made a bored one. Then we are removing the part and then we are adding another foreign material. So that is nothing but, so here we have 3 different things going on there. So generally what students do is that they will be seeing only the numbers. So here they will see that, sir, here I have 1 and 2. Why can't we have v1 x1 minus something like that? So if they are using that, the logic becomes absolutely wrong. So in this case, what they have to do is that, so here the densities are also different. So here the formula gets slightly changed as x bar equal to rho 1 v1 x1. So this rho 1 v1 x1 denotes the perpex cylinder which is unmachined. அதாவது unmachined இல்லாம ஒரு ரெகுலரா அந்த சிலிண்டர் தான் வந்து பாத்தீங்கன்னா rho 1 v1 x1. Next we have made some drill. We have made a drilled one so that we are removing some material from there. So that is going to be rho 1 v2 2. Then we are filling the material. We are filling that by using lead. So we will be using plus rho 2 V3 and X3. So divided by rho 1 V1 minus rho V2 plus rho 3 V3. And similarly for y bar also. So for y bar we will be using rho 1 V1 Y1 minus rho 2 V2 Y2 plus rho 3 V3 Y3. So divided by
சார் ஸ்க்ரீன் மட்டும் ஷேர் பண்ணிடுறீங்களா?
screen மட்டுமா சார்?
ஆமாம் ஆமாம்.
சாரி சார். So now is it visible sir?
இல்லை அந்த உங்களுக்கு ப்ராப்ளம் கொஷின் மட்டும் தான் விசிபிளாக இருக்குது. நீங்கள் இப்போ எழுதுறது வர மாட்டேங்குது.
எழுதுறது வரலீங்களா? ரெண்டு ஆகலீங்களா?
இல்லை ஒரு நிமிஷங்க. வருது ஸ்லோவாக வருது
சார். ஆக்சுவலாக அந்த மாதிரி ப்ராப்ளம் வந்தது இல்லை சார். நான் வீட்டில் கிளாஸஸ் எடுத்திருக்கேன், ஆனால் இந்த மாதிரி இஷ்யூ வந்தது இல்லை.
அதான் நெட்வொர்க் ப்ராப்ளமாக இருக்கும் போல
சார். வெதர் ப்ராப்ளம் இருக்குது சார். வெதர் ரிப்போர்ட் தான் இருக்கும்.
ஆமாம் சார். இங்கன்னா ஒரு வந்ததுலேருந்தே கொஞ்சம் மழை பெய்யவும் கிளம்சியாக தான் வெதர் இருக்கு. ஓகே, யூஸ் ரோ 1 V1.
சரி, இன்னும் வரல.
இன்னும் வரலீங்களா?
வரல. சரி சார், உங்களுக்கு தெரியுதா? இல்லை ஒரு வேளை என் சைடில் தான் இஷ்யூ இருக்கும்போது.
இல்ல ஒன்றும் வரல
சார்.
வரலீங்களா சார்?
சார் நீங்க என்ன பண்ணுங்கன்னா திருப்பி வெளியில போயிட்டு அப்படி இது பண்ணுங்க. ஷேர் ஸ்டாப் பண்ணி திருப்பி ஷேர் பண்ணுங்க.
இல்லை அப்படிதான் பண்ணியிருக்காரு.
இப்போ ஸ்டாப் பண்ணிட்டேன். இப்போ திரும்ப நான் ஷேர் பண்றேன் சார்.
இல்லை ஒரு செகண்ட் விட்டு ஸ்டார்ட் பண்ணுங்க.
ஓகே. இப்போ பண்ணட்டா சார்?
பண்ணுங்க.
வருதுங்களா சார் ஸ்க்ரீனு?
இல்லை வெயிட் பண்ணுங்க.
சார் இப்போ தெரியுதா சார்?
வரல சார்.
சார் இப்போ வந்திருக்கா சார்?
சார் இன்னும் விசிபிளாக இல்லைங்க சார்.
வரல சார். வரல
சார். ஷேர் ஆக தெரிஞ்சிருக்கு சார். பிரதீப் சார் இப்போ வந்திருக்கா சார்?
சார் இல்லைங்க சார், ஷேர் ஆகலை. உங்களோட இது மட்டும் தான் இருக்குது, ஸ்லைடு ஷேர் ஆகலை.
சரி மிஸ்டர் ராம்குமார்,
எஸ் சார்.
நெக்ஸ்ட் நெட்வொர்க் எது சரியா இருக்கோ அப்போ வந்து நம்ம கண்டினியூ பண்ணிக்கலாம்ப்பா.
ஓகே சார், சரிங்க சார். சாரி சார், சாரி ஃபார் தி இன்கன்வீனியன்ஸ் சார்.
பரவாயில்ல.
4G தான் யூஸ் பண்றேன் சார். இது வரைக்கும் இந்த மாதிரி ப்ராப்ளம் வந்ததே இல்லை சார். ஏர்டெல் 4G தான் சார்.
சரி. சரிப்பா.
சாரி ஃபார் தி சார்.
இல்ல, நோ ப்ராப்ளம். ஓகேப்பா, ஓகே.
தேங்க்யூ சார். தேங்க்யூ சார்.
தேங்க்யூ ராம்குமார் சார்.
தேங்க்யூ சார்.
தேங்க்யூ சார்.